Hello students, myself Vijayalakshmi Sadlapur, Senior Grade Lecturer, Government Polytechnic Vijaypur, Department of Collegiate and Technical Education, welcome you all on an interesting session on a graded exercise related to your third semester C Programming Lab of Electronics and Communication Engineering. The problem statement we are going to solve in this session is: given the resistance and its tolerance, we have to find out the color bands of that particular resistor. The prerequisites required for this session is you have to know the color banding or color bands of the resistor. You have to know about the pointers of the resistor and also the use of lookup table in your programming. This is a table of contents which we will be going through in this session. First, we will go through what is an algorithm and a flow chart. Then next we will go through the actual problem statement. Then we'll execute the program using your Turbo C, and we'll just have some simple MCQs related to your C programming. Well students, as we are all from the electronics background, we know what is a resistor. Usually what we do is whenever you come for your circuit lab, we provide you the resistors. So you look at the resistor, you go through the color bands given on the resistor and you find out the value of the resistor. But I'll make it clear here in this program that we are going to give you the value of the resistor and you have to find out the color code. That is, we will be giving you the user will have to give you the two digit value along with the third value, that is a multiplier, and the tolerance band. So once these four parameters are given to you, you will find out the color code of the resistor. So this is what we will be doing in this program. So in order to implement this program, here I am going to use the concept of lookup table. So now what is a lookup table? Lookup table is nothing but it's a pre-calculated value or the table, and it is stored in a program storage. If you just recall some examples, now if you want to write the multiples of a given number, or if you want to generate the sine series, so in all these examples the outputs, they are fixed, they are all pre-calculated. So in such cases what we do is we will generate an array, okay, of these values, and we use those values in our program to speed up the calculations. So this will be more clear when I use a lookup table in the program. We'll just go through it. Now we'll write the algorithm for the given program. Before that, I'll just define the what is the algorithm. So students, whenever a statement is given to you or whenever a program is given to you, what you have to do is we will just first think about how to write the program, or what are the steps or what is the procedure we have to follow in order to get our required output. Okay, so we first write a algorithm, that is we write a step-by-step procedure. Okay, so that is nothing but the algorithm. So algorithm is nothing but a step-by-step procedure to write a given program. Okay, so along with that, let me define the flowchart also. Once we write the algorithm, we are going to define that algorithm in a graphical representation. Okay, the graphical representation of the algorithm is nothing but a flowchart. Okay, so here, this is the algorithm for our program. So as already I said, the values of the uh, your the values of the resistor will be given to you, and you have to calculate what is the, or you have to find out what is the band, color band for that given values. So we first start the program, and here I am going to define the lookup table. So when I define the lookup table, as I already said, we are going to write it in terms of an array. We will be declaring the lookup table in terms of the array. So the array size will be depending upon the contents or the number of values you are going to store in that array. So now here this array will start from what? 0. So black is, if I just store the value, like if I say color of 0 is black, color of 1 will be brown, then color of 2 will be red, and so on. Okay, so like this I am going to generate a array which is nothing but the lookup table, and first I am going to define it. Then next I have the tolerance bands, that is also fixed, which is also pre-known. So what we do is we set up these three things: 5, uh, 5, when I am going to give the tolerance of 5%, then it will be gold. 10%, then it will be silver. If it's no color, then it will be 20%. So we are going to define these three also in a array. Next, we take the inputs from the user in terms of two digits, that is A and B. These are the two digits which we take. These are the this is nothing but a two-digit value. This is a two-digit value of your resistor, which you have to find the color code. The next, the third is the multiplier. Okay, the third is the multiplier, and the last number is your tolerance band. Okay, then next, once these values are given to you, what we do is we go through this lookup table. Okay, we go through this lookup table and we are going to find out its equivalent color bands. The next, C is assigned the multiplier band and tolerance is assigned the tolerance band. So finally, we given the values of A, B, C and a tolerance, that is the two-digit value of your resistor and the multiplier band along with the tolerance band, we will be able to find out the color code along with the tolerance band of your given value of the resistor. So this is a simple algorithm which we are going to write. The next, the same thing I have here represented in using the flowchart. So first we will declare the lookup table. Then here I am going to take the three inputs from the user. Once I take the inputs, it goes to the lookup table. Okay, these inputs will be related to the these two values will be these three values they will be related to this lookup table, and through that we are going to assign the values. Like I'm going to assign the color band 1 to A, color band 2 to B, color band 3 to C, and color band 4 is for the tolerance. Okay, and lastly we display that result. So this is a simple flowchart related to the program. Now we'll just go through the actual program. So we are already knowing the knowledge about using your header files. That is, in this program I'm going to include stdio.h. I'm not requiring any other preprocessor directives. This is sufficient for me. The next, we are going to declare the main, and here we are going to declare the inputs which we want, which are of the type data type integers. Okay, A, B, C and D. Here is a new thing, that is I'm going to here declare an array, the point of pointers. Okay, so here I have a pointer of array of size 10, okay, sorry 11, and I'm going to define a pointer for that which is of the type of what, character. Okay, so how this will be declared? So if I say color of 0, so color of 0 it goes to be the black, color of 1 it goes to be your brown, and so on. So here I am going to initialize my lookup table. So in the same way I am going to declare a pointer to the array of tolerance. Okay, I'll just declare some value of a pointer of the tolerance which is again of the type character, which is of the size 21. So either I can follow the same method, but as I have only three defined values of gold, silver and no color related to 5%, 10% and 20% respectively, I just directly declare these three things in your tolerance pointer. Okay, so this is all the initial setup we are doing in our program. Okay, this is the first part of the program. So whenever you are asked to write a program, we first think about the input and then we think about the process and lastly the output. So here also what I am doing, I have now taken all the inputs and I have declared the your lookup table for your color bands and also for your multiplier, and then next I have declared the pointer to your tolerance bands also. Okay, so this is the first part of the program where we have set up the inputs. Then next, here is about how we are going to use the scanf. Here I am going to use the scanf statement to take the inputs from the user. So first I am going to enter the value, see, and I using the printf statement, I declare a statement to your user wherein I ask the user to enter the values of A, B and C. Okay, then next, that is here we are going to enter the first two digits separated by a space. Okay, so that is we are going to use now take the inputs A and B. Then next, that is here I say scanf which is the input statement, that is and A and B. Okay, so now I have taken the two values. In the same way we are going to get the input value of your C. Okay, So printf, enter the multiplier. So again using a scanf statement, I take the value of C. The next, what is one more input required? I'm going to have the tolerance. So in order to get the tolerance, I say enter the tolerance. Okay. So by using again the scanf statement, I take the value of T. So this is how in this part I have explained about how you are getting the inputs from the user. Okay, I hope this is also clear to you. Then next we'll move on. So this is just a single line of your output, how you get your output. Okay, so just what we do is, as I have already declared the values of your A, B, okay, and C, and also your tolerance T. So I have declared all these values. So just what I do is I go for an array, that is which your lookup table, wherein I say it is a color of A, color of B, color of C, and tolerance of T. Okay, so just after getting the values here, we go for the lookup table. Okay, this is a color of 10. This is the array which I have declared. So I go to this and I pick up that respective index. Okay, I just pick up that respective value from this lookup table. So that is done here. What I do is color code is color of A, color of B, color of C, and a tolerance T. Okay, so this is how by using just a single line, as we have used the lookup table here, by just using a single line I can get the output of your program. I'll just see one simple output. So here when I execute the program in your Turbo C, it asks to enter the value in the format of AB into 10 raised to C. Okay, so first enter the 2-digit values. So if we enter 4 and 7, you remember this value 4 and 7. The next enter the multiplier value, that is 2. Enter the tolerance value, here it is entered as a 10. Okay, now you just remember 4, 7, 2 and 10. If I go back to this lookup table, see 4. 4 stands for what? It is 0, 1, 2, 3 and 4. 4 stands for yellow. Okay, 4. 5, 6, 7. 7 stands for violet, isn't it? Yellow and violet. If you just see the output here, see we have first two numbers as what? Related to your 4. Okay, so related to your 4, I have yellow. Related to your 7, I have violet. And related to your 2, I have red. Okay, so this is the color coding. The next related to your tolerance. If you just again see the assignment, so 20. If 20 is the input, sorry, 10 is the input, then it is nothing but it's a silver. So the same way here we are getting the value as what? If it is 10, I'm getting it as what? Silver. So this is the output how we are going to get. Okay, so this is how we are going to have first the algorithm, then related flowchart, and we have also gone through your program. Okay, I will just see the execution of this program. I'll just execute the program by opening your Turbo C. So this is the Turbo C what I have opened. So already I have opened the program. So once I open the program, the program is complete. Just I need to compile the program. So once just compile. So the shortcut key for compiling is what? Alt F9. Okay. So here. So you can just see that there are no errors and warnings. Then next we can run the program. See, enter R in ohms in the format of what? A, B into 10 raised to C. Okay. Now first enter the 2 digits. I'll just enter 2 digits separated by the space 1 and 2. Okay. So this is over. The next enter the multiplier C. I'll enter the number 3. Now what is the output we are getting? Okay, one more input is what? I have to enter the tolerance. If I just enter it as 5, okay, it's in terms of percentage, enter 5%. Okay, now you see we are getting the output. So what is the output? Related to your 1 and 2, we are getting it as brown. Okay, brown, red, orange and gold. So this is how we have executed the program. Okay, so if you just remember, I have entered what? 1, 2 and 3 and 5. So what is the output I am getting here? Color coding is brown, red, orange and gold. Okay, so this is how we have executed the program using your Turbo C. Okay, so if you just again if I just open my lookup table, what was the value I have entered? I have entered the value as what? 1. So it is 0, this is 1. So this is this will be for 0, this is 1 and 2, that is brown, red. Okay. Okay. And then it is what was 3. 3 is nothing but the orange, and I have entered the tolerances at what 5. So gold was my tolerance band. So this was the execution of your program. Now we'll just go through some of the MCQs. See the question. The logic required for implementing a program can be expressed in terms of, okay, but that is flowchart, algorithm, flowchart and algorithm, none. So what could be the answer? We are going to implement the logic required to write a program. Okay. Yes, the answer is what? We have to use both the flowchart and algorithm. Both are the right thing. Okay. The next, what is a lookup table? It is nothing but a pre-calculated and stored values in your program storage. Let's go through the next question. Algorithm is a step-by-step procedure to write a program, whether it is true or false. Yes, it is true. Okay. The next, indentation while writing the C program is mandatory, whether it is true or false. Do we need indentation? See, indentation is nothing but we have to use the tabs. Okay. Like for example, in ARM we use the tab, that is the indentation. Okay. So in the same way, is it required here for your C programming? No, it's not required. Whatever indentation we use, okay, that is just for our understanding, our legibility. We use some indentations which is not mandatory. Next, C programming language is not case sensitive. Is it true or false? Is your programming case sensitive? Okay. See, our C programming is case sensitive. But what is the thing I have written here? I have given C programming language is not case sensitive. So here the answer comes to be false. Next, the header file to be used for IO operations. So what is the only header file I used in this program? Yes, it is just nothing but stdio.h, standard input output. Okay. The next, prior of declaring a pointer, it must be declared, it must be initialized, and both. So whenever I am going to declare a pointer, it has to be declared and also it has to be initialized. So both is mandatory. So your answer is C. Next, the comment on the following, that is, I have given a statement here, int star p comma p. So what does this mean? What does this line mean? See, pointer is, ptr is a pointer to the integer and p is not. ptr and p both are pointers to the integers. See what I have done here, I have declared a pointer of the type int and I have declared one more variable which is p. So amongst these two comments, which is correct related to this? Yes, it is A. See, p is nothing but it's a new variable. It's not related to the pointer. It is, p is a variable of the type int. Pointer, ptr is a pointer which is of the type int. Okay. So this is the thing. Next, which is the following? Which of the following is the correct way of declaring the pointer? So just go through this. That is, here I am just showing you the what you can say is declaration, syntax of writing a pointer, syntax of declaring the pointer. So float ptr, float star ptr, star float ptr, and none of the above. Okay, this is again a very simple question. It is of course what? Float star ptr. That is, here pointer is indicated by the star. This variable ptr is having the star. Okay, and it is of the type of float. So this is the correct way of declaring your pointer. Next, in the above statement, in the below statement, ptr pointer 1 and pointer 2 are uninitialized pointers to int. That is, they are pointing to some random address. Okay, that may or may not be a valid address. So whether it is true or false. Yes. So just now we have gone through one of the thing that the pointer has to be initialized, isn't it? But here they are uninitialized. So what happens if they are uninitialized? Okay. What is been saying here? They are pointing to some random address. Okay. That may or may not be a valid address. It is false because once they are initialized, they point to a valid address only. Okay, so that's why this statement is false. So these were some of the MCQs which I've gone through. So the references I've used for this presentation is, I've used Balaguru Swami's Programming in C and Yashwant Connector's Let Us See. And well, this is the team. We are working on the content development related to your C programming lab of third semester. Thank you.